Welcome to the channel. Today we will be covering silicon on insulator technology. So silicon on insulator means we will develop a layer of silicon taking insulator as a base material. So sapphire is the insulator here, and the red color region which I am marking is the silicon. Okay, so in this technology, once we grow the silicon on insulator, okay, we just make use of mask and photoresist in order to come to the third stage. In the third diagram, you are seeing that we are forming two islands. So these two n minus regions are called as islands because the analogy is the insulator, which is marked in yellow color, it acts like sea or ocean, and the silicon which is grown over the uh, insulator looks like island. Okay, in previous technologies we were calling those as wells because they were looking like well in digged in the earth. So now this is an island. Okay, so here as we are seeing, we in the second step what we have done, we have made use of some photoresist and SiO2. Then what we have done, we have formed the islands. Okay, and now these islands, one is, both are n. Okay, we will convert one n to p. So one n island will be converted to p, so that in the n island I can form the n MOSFET, or in the n island I can form the p MOSFET, and in the p island I can form the n MOSFET. Okay, so we'll proceed further. In the next step, what we are doing is we are covering the n island which is present on the right hand side, and what we are doing, we are implanting the boron. What is boron? It is trivalent. So this n island which was there in the third step, okay, left hand side, that is converted into p type because we have implanted the p type material. Next what we do, we will cover this p type island, and then again what we do, we will implant the n type material. Okay, so now exactly what we have is, left hand side we have uh, p-type semiconductor, and right hand side we have n-type semiconductor. Okay. Now what we do in the next step, we'll grow a thin oxide layer, fine, and so the red color is the oxide layer, and the purple color is the polysilicon, which acts like gate. So we are moving towards the MOSFET formation. Red color is the thin oxide or SiO2, okay, and the purple color is poly, which acts like gate. Then again, what we do, we repeat the steps of masking and photoresist. Actually, it is called as photolithography. So using those steps, what we do, we just etch the unwanted parts. So actually we needed the poly or gate to be formed on SiO2 only in this region, which I am marking purple in color. Okay, and we have the oxide layer below the gate, fine. And next what we do, we will implant, actually we will uh, so in next step, we will cover the right hand side. Right hand side is completely covered, and on the left hand side what we do, we will try to form the N-type MOSFET by implanting N-type material, which is phosphorus. So here you are seeing the implantation of phosphorus. So the poly which is there at the center, okay, that is protecting the center layer. Therefore, actually it was P type, right? So this P type has been retained, as you are seeing the yellow color marking, because the poly, it has prevented the implantation at the center, and the other regions, they are implanted by N type material. So we have N, P and N. Similarly, the same step is repeated on the right hand side. We have covered the left hand side, and now we are implanting the uh, P type material, which is boron. So as I said again, the center part, it is retained as N minus because it is covered by the gate or polysilicon, and other regions will be becoming P type because we are implanting P type material, and even left side is covered, so there is no effect on the left hand side. In the final step, what we do metallization, or contact cuts are formed for doing the connections, and we bring out the terminals outside. So you can see this P-type MOSFET. Okay, the source is connected to VDD. You can see the shading, right? And drain is connected to drain. So we are forming the inverter on SOI. Okay, so right hand side is P device, and you are able to see this VDD connection is shorted to the source. Okay, and VSS connection left hand side is shorted to the source of NMOS. The drain is shorted to drain, okay, and this gate is actually shorted to gate, but we are not able to see, it is behind the screen. So you can imagine the 3D diagram. Gate is shorted to gate. Okay, so finally what we are having an complete inverter grown over the insulator. This is called as SOI process because silicon is developed on the insulator. Thank you.